Hi, thanks for coming. I'm Federico. I work for the cloud team of Enter. I learn and teach in Loged and OpenTech School Milano, and I'm a Docker community leader here in Milano. In the last month, I've attended two main conferences, one in Copenhagen, DockerCon Europe, with Diego, Riccardo, Mattia, lots of people are here tonight, and also the OpenStack Summit in Sydney. I don't know what do you think about the last announcement at those conferences. I think that work with open source nowadays, it's really being part of a big community, so I like it, but the problem are always the same, you know. It's integrating all the technologies. And if you think about cloud native, computing foundation, you know, it's addressing this problem. It's a common home for lots of components, a lot of cool technologies. And if you think at this landscape, there are lots of categories. One, it's observability. Observability is a cool and trendy term, covering different aspects of monitoring. But one of these, it's the Evergreen Tracing. So basically, what happened in your program. But what happened when your program became a distributed system? Do you know what is a songline? Yes. I learned this concept in Australia. It's not easy to explain, but I try. Also in English, it's not easy as well. In Australia, the elder Aborigines use songlines as a method to find out the way to while they are moving across the country. So in Australia, for Aborigines, there are invisible lines everywhere in the country. So for those who don't know me well, I love to mix and match tech and non-tech topics. So this is one of that. In my mind, this remember me what OpenTracing does in our stacks. Because if you think all the traces are like travel, no, of our interaction with our programs, and the travel, all the parallel tracks are consist of small paths, like span. No, the name technically is spans, that are basically, you know, from the beginning to the end, all the travel, and the overall, system, it's composed of so many tracks, so many traces, and but if you think on a single trace, it's directed because it's just the travel from the beginning to the end. So technically speaking, is a directed acyclic diagram. OpenTracing is distributed, so as I told you, it's for not just for one host, not just for one system, but for a distributed system. It's neutral. OpenTracing could work with several different languages and also several different traces. One of these traces is Jaeger. Jaeger is obviously compatible with OpenTracing, and it consists of a client part, so you can use the client libraries, you know, for instrumenting your application. You can intercept the context of your application, and you can send the trace, so basically the information that something happened, to an agent that is working on the host, and then to a central collector, from the central collector to a storage, basically Cassandra. And then you can process all the traces with a query language, you know, and at some point you have a cool dashboard to see everything. I want to show you how we use OpenTracing for our technology for example, in our automation platform, but I want to introduce it a bit before the demo. It's a microservices architecture. We have an API and two main components. There are manager, one for traditional application and one for containerized application. So several components, and the problem is, you know, the communication between different components. For the communication, we choose gRPC. gRPC is a modern RPC framework. It's open source with high performance, and use protocol buffer. So basically, you have to define messages in proto buffer, and the communication could be from different client and server with different technologies, with sharing just the proto buffer and the implementation, of course, of the gRPC endpoints. OpenTracing, gRPC use HTTP2, so in a single TCP connection, you can share multiple gRPC calls, also with bidirectional stream. So it's time for a demo. I want to show you quickly, because of the pizza, our dashboard. Basically, this application manage traditional application, the life cycle of traditional application and of containerized application, starting from the infrastructure. So it's not a manager, only a manager of application, but also starts from the very, very bottom, the infrastructure level. So I can show you in an inventory. For example, your application could start from a few servers. One of these servers, for example, could be a Docker Swarm cluster. So in a Docker Swarm cluster, you can create an application. The easy way to create application, you know, it's basically using Docker stack. So an application for us is For us, it's a Docker stack, so a Docker Compose. You can add these, for example, I don't know, Nginx. You can add a few options like an external registry where we can pull the images, volumes, because we want to share, for example, configuration with the cluster-based volumes. You can add secrets because of your passwords and security stuff. And then you can spin off everything. So deploying, saving and deploy, just one step. And now you can see we have a new application. You can see, as always, the service and the container. You can launch the application, okay, nothing special. And you can see, for example, a terminal, so you can interact with the bash. You can see, you can inspect the configuration, see the logs. So this is also, you can see everything from the inventory, so from the perspective of the infrastructure. And this is true also for traditional application. So if you want to launch, to deploy, for example, a traditional application with Ansible stuff, you can configure a playbook and run the playbook with the API or clicking on this button. But what about OpenTracing? OpenTracing, we use OpenTracing everywhere. So we use OpenTracing with Jaeger. And for example, I can start from the diagram. So you will see when you deploy, for example, when you interact with our infrastructure, for example, with the Docker cluster, starting from the web, so from the API, you can call the Docker manager. The Docker manager basically a controller, like, you know, if you know what Docker Swarm does, it's an orchestrator with a manager and a worker. So basically you call the manager to collect all the services and to deploy. And only if you want to interact at the container level, you can call the agent on the Docker node. I think that Jaeger is cool, the dashboard is cool, because you can see many things. One, it's basically all the traces. So you can, for example, you can see that all the calls now between the components takes some microseconds. You can see all the steps of your calls, all the spans, and also you can get an idea of the latency between the communication, because if you see here, you have a timeline with all the response time. So it's common, very common to see during the day the latency. And if you want to understand exactly the data flow, you can go through the interfaces, opening all the spans and looking for also logs, errors. So it's basically it works not just for tracing but also for logging, so kind of observability. Okay. Voila. I go on quickly to just few other words about our travel with this technology. So we have been working with all of these technologies. I mentioned gRPC, Golang, that's the language we use for integrating all the stuff, Jaeger, OpenTracing, and Docker as a runtime for everything. The glue between gRPC and OpenTracing, it's this library gRPC OpenTracing. It's a kind of middleware and interceptors that catch all the traces in gRPC and send it through the OpenTracing API, so finally to Jaeger and Zipkin, or whatever you want to use. For the next future, we want to add Prometheus for monitoring and also Kubernetes as another backend for our application. Not just I love personally Docker Swarm, but you know, Kubernetes, it's the next. Thanks.